Hey guys, today I'm going to show you in this video how to draw the Lewis dot structure for hydroxide ion, which is OH minus. So here we go. OH minus is going to give us 6 valence from the oxygen plus 1 valence from the hydrogen plus 1 more because it's a -1 ion. So it's going to give us a total of 8 valence electrons. Okay, so what we're going to do, because it's only got 2 atoms, just go ahead and draw OH and join them with a single bond. Now hydrogen can only have 2 electrons total, so this bond is done and nothing else can be over here. So that's 2, so 8 minus 2 is going to be 6. We have 6 more electrons left, so 2, 4, 6. Oxygen now has the full 8 electrons, which gives it the octet, and hydrogen has 2, and so that essentially is done. Now, however, with ions, you also have to add the box, square brackets around the structure, and indicate the charge overall. So this is OH minus, which is a -1 charge up here in the top right. So this appears to be right. So let's go ahead and draw or check the formal charges just to verify that this is the correct drawing, correct structure. So the formal charge of the oxygen, start there, is going to be valence brought in 6 minus number of bonds 1 minus the number of non-bonding electrons 1, 2, 3, 4, 5, and 6. So minus 6. That's going to give us a -1 formal charge for oxygen. Now we have the formal charge of the hydrogen is going to be valence brought in 1 minus number of bonds 1 minus number of non-bonding electrons 0 is a formal charge of 0. Now if you sum up these formal charges, -1 plus 0 is -1 overall. The sum of the formal charges for ions has to match the overall charge of the ion itself. So the sum of the formal charges is -1, the charge on the ion is -1, and that's exactly what we're looking for. So that's very good. That's what we're trying to get. Okay. Now, in terms of shape, how this would look, it has it's going to be AX1 because there's 1 bonding atom, and there's going to be E3 because there's 3 non-bonding pairs of electrons. So because there's only 2 atoms, it's actually going to be a linear shape, and so that would mean that the bond angle is 180 degrees. That's not really tested on ever, but it's good to know. And it's going to be polar because the electronegativities of hydrogen and oxygen are definitely different. So the oxygen is going to have much more of the negative charge towards it, which is also why it has all these extra electrons over here. So the charge distribution is certainly not going to be equal. So there's going to be definitely more of a negative charge by the oxygen, which would then make this a polar molecule overall. That's pretty much it. If you have any questions, leave them in the comments or send me a message. If you have any requests for certain kinds of molecules or compounds, let me know. And thanks for watching.